Hello, everyone. Good evening to you all. So let's give the rest like 2 minutes and then we can start off.
We bless you, Lord. We bless you. Worship you, Jesus. Worship you, Jesus. Your voice. Your voice. We give you blessing. Yes, yes,
Hi everyone. Give us like 2 minutes. We are sorting some technical issue with the speaker. Yeah.
blessing your
Okay, so I believe we can start now. Again, good evening, everyone. I hope we've had a lovely week so far. So I'll go ahead and begin with just introducing our topic. So we'll be talking about secure software development. And with us, we will have Charles Njuguna, who is our speaker. He's a senior system reliability engineer at Safaricom, and he will be telling us about secure software development, what the industry expects, and the do's and don'ts. Yeah. So I'll just go ahead and introduce Charles, and then we can start off. So Charles is a software engineer with a passion for building scalable, high availability, and secure systems. He's focused on driving automation, improving operational efficiency, and enhancing system performance through monitoring and observability. He has experience in cloud native applications. He is dedicated to delivering reliable solutions that drive business value. So, we'll give Charles the chance to tell us about himself, what he does, and exactly what secure software development entails. So, karibu sana Charles. Welcome to Cyber Shujaa Job Hunting and Mentorship Session.
Okay, good evening and thank you, Hope. I hope you can hear me clearly. Am I audible?
Yes, you are. Someone
Yes,
else
sir.
can comment. Yeah.
Okay, thank you. So, as Hope has said, I'm Charles Njuguna. I'm a software engineer at Safaricom. Current role is SRE. So, maybe just to give a context of what SRE is. SRE is a site reliability engineer. Basically, we just build systems and make sure that other systems are up and they are reliable, and maybe we can be able to forecast some issues before they happen, just to make sure that our customers get the best experience when using our service. So, diving into today's topic, which is secure software development. So, just go ahead and share my screen just a moment.
Charles, you have a bit of background noise.
Okay, just a moment. I hope that's sorted now. You can confirm from your end.
Yes, we're good.
Okay, great. So, when we talk about secure software development, maybe what comes into your mind? Every day we're interacting with softwares. Our lives nowadays have been revolving around softwares. Uh, Everything like your mobile phone from morning, maybe from when you woke up. Probably majority of you, when you wake up, the first thing is just you pick your phone and you just start scrolling. So softwares have become part of our life, and making them secure or maybe building secure uh, software is key when it comes to maybe dealing with customer data, also making sure that we don't expose what should not be exposed. So when we look at the broad uh, the broad software, what software entails, we have web applications, we have mobile applications, uh, we we have embedded systems. We have to build them securely, and there are different ways which we can be able to secure this system. Maybe using some login credentials, using some multi-factor authentication, and other stuff that we'll see as we go on. So when building an application, you have to think like a house. I like to put it in the context of like building a house. You have this mansion which has valuables inside, maybe some was $100,000, some was $1,000. So you have to make sure that maybe the place where you keep these items, they are secure. It's not easy for anyone who come around to can access them, maybe steal them. And in the modern world, one thing that you'll know is quite valuable. It's being sold at very high cost is user data. So we have to secure it. We have to make sure that when we're building system, user data is all secure. And there are different ways. I know the room is full of people with background in security, and you probably understand this more than maybe some engineers do. There are different ways in which we get the threats. They could be SQL injection, they could be cross-site scripting, they could be maybe cross-site request forgery, and remote code execution, among many others. Uh, maybe to a layman, these terms could be a bit difficult to understand what they do or maybe what they mean. For instance, if you look at something like SQL injection, maybe if you build a system that is not well validated, the inputs are not well validated, you might find yourself exposed or maybe vulnerable to SQL injection. And if someone manages to access the database, they have managed to maybe get the most valuable information we talked about, which is user data. And there are so many things they can do with that information. Maybe they can decide. Let's take, for instance, it's a transaction system. Maybe something like a transaction processing system, like a fintech, a bank, or something like that. Uh, if you manage to access, uh, or maybe if you manage to do some SQL injection on such a system, uh, the the entity or maybe the business could incur a lot of loss. Maybe you just go and delete all you do an injection to go delete all the user information on that system, and maybe they don't have a backup, or even if they do have a backup, maybe it will take them some few hours, few minutes for them to be able to do some recovery, be able to probably do some patching, and if the system is critical, they might be counting losses or when maybe doing that. So how maybe do we avoid things like SQL injection? One of them is when you're building an API, you have to do the input validation. Probably you have to look if there are some scripts that can be, that can cause some issues to your data, or maybe can affect the data integrity. Uh, you have to do validation. So one of the basic things to avoid an item like SQL injection is doing your validation well, making sure that all the inputs that come in are properly validated. The next thing that maybe we can look at in the context of the backend security, or maybe building secure backend, is how maybe can we avoid something like API abuse. Maybe I can explain that a bit. API abuse could be something like maybe you have an API to log in a user. Probably you don't need to get too much information about this user. You just make sure you get the minimum amount of information you require from a user. Probably you just need a username and a password. You don't need to to go asking them for things like their address, their location. If at all the application will not break, or maybe the functionality of the application will not break, you don't need to go asking them um, to provide such uh, type of information. The other thing maybe we can look at when we talk about uh, the secure backend. Okay, I think I'll use uh, a term backend because that's where most of the information, or maybe you interacting with the database where the user information is, which is key. The other thing we can talk about is how do you make sure that your application don't leak data? Um, are you using a secure protocol? If at all maybe you're making some HTTP request over the internet, are you making sure that whatever uh, data you're sending or receiving, does it go through a secure protocol? I know, okay, maybe it could be in the modern day and age, could be maybe difficult to find someone who is exposing a HTTP endpoint for a production service. But in case maybe someone just decides to know, they don't want to purchase certificates and do stuff like that, you find that maybe they might end up exposing a lot of data by using HTTP protocol. Uh, huh. So when we look at the best practices that we can do to make sure that our backends are secure and they are not exposed, one of them I had talked about is something like doing input validation. Another thing is making sure you just get the data that you need from a user. Another important thing that you can do in building a secure system is introducing something we call rate limiting. Okay, I don't have much slides, so most of this information, maybe you can just be noting it down. I'm more practical person than writing. Um, you can do something we call rate limiting. So what is rate limiting? Let's take for instance you have an endpoint um, that is of high TPS. TPS is maybe transaction per second. Maybe let's say this endpoint expects, or maybe it's doing like 1,000 TPS. So out of these 1,000, you want to make sure maybe each user have access to that endpoint within a second, maybe one. So that's where the rate limiting comes in. It just makes sure that maybe a call that is coming from a particular user, or maybe a particular IP to your service just uh, happens within a certain period. Maybe you can even say 5 seconds. I don't know if you've seen these where you maybe try to, okay, I'll give an example. If you try uh, to purchase some MBs, maybe using star 544, and well, okay, let's not use that. Let's say, take for instance, you want to send 100 shillings to a certain number, and then within the same minute you try to send again, and then within the same minutes, I think they usually allow like 3 times. You can, I'm not sure, but you'd find that after a certain number of times, or maybe a certain number of attempts, you get that your request is, we are processing similar requests, so we'll not be able to proceed with your request. So that's a good example of how rate limiting works. It's applicable in the APIs where you can limit the amount, or maybe this will help you to avoid DDoS attacks. They cannot be avoided 100%, but to some extent you'll be able to avoid, or maybe you'll be able to limit the amount of maybe if the DDoS attack is not well organized and is not well distributed, it's something you can be able um, to protect your system against. So uh, the way it works, you as an engineer, you can be able to set different parameters. Uh, Maybe if a user makes 5 requests with the same payload from the same IP, you're going to block in the next maybe 5 minutes, 10 minutes, or maybe something like that. You as an engineer, you'll be able to do that. Uh, when we look at maybe libraries you can use, um, if maybe you're in Java, or maybe you're building a system using Spring Boot, there's a very nice library called the Resilience4j, which you can use to incorporate rate limiting in your application. The other thing maybe we can talk about still around the same is circuit breakers. So just like in lighting, when a circuit is complete, maybe the bulb goes on. That's the basic of a circuit. So maybe you have power flowing from this direction to the other direction, and the bulb powers on. Same can be achieved on your application, on your software application, on your backend service. You can incorporate some circuit breaking, especially for distributed maybe microservices. Uh, so microservices, maybe you have different services, small services that are communicating between each other, could be making HTTP calls between one service and another service. Uh, so maybe if let me give this example. You have let's take an example of an e-commerce system. So in an e-commerce system, we could be having multiple microservices. One of them we could be having a microservice for security. So the one for security will just focus on making sure that all the users are authenticated and all the requests are authenticated. Maybe from there we can have another microservice that handles um, orders, and probably we have another one that handles the inventory. So the one for inventory will just check if maybe the item is there, if you're adding a new stock, that will go through the inventory service. So let's take, for instance, you've done your load balancing, or maybe you've done your scaling of the application. So maybe you have inventory service because it's handling a lot of requests, the ones that are coming from the order and the ones that are coming from the new items being added to the inventory. So maybe you have several services. Probably you have something like 3 services running, or maybe something like 4. When a user comes to your e-commerce, probably they're just going to select items, add them to cart, and click on place an order. Before we place an order, we need to confirm if maybe that item exists on the inventory. So we make a call to the inventory service asking it, hey, do you have this item? Do you have this item and this quantity of this item? And the inventory service will tell us, yes, this item is available. And now the order will proceed to checkout. And then from maybe checkout, we proceed to something like payment. So let's say the inventory service, which have we'd say 4 services running, it's getting overwhelmed. The requests that are coming in, they are overwhelming. And for that case, it's taking time for maybe an order to be confirmed if the item is available to proceed to checkout. So in that case, you don't want customers to, to stay waiting. The cart is just loading for 5 minutes. It's quite annoying. So um, what we can do here to make sure that we avoid such inconveniences, which could later lead to the whole application crashing because of timeout. Every other service is timing out. We can introduce a circuit breaker. So the way it works and the way it's designed to work, it has three states. You have closed state, open state, and half open state. So in closed state, it means everything is okay. Everything is working as expected. So in that state, all the requests are coming in and going out within the stipulated time for each request. And then we have half open state. So half open state is when you have maybe it's experiencing some strain and the requests are taking a bit long. So maybe if your application was handling 1,000 transactions per second, that's 1,000 TPS. Maybe it's now being able to process something like 500 TPS, or maybe it's for some reason, could be some network issues, the TPS has dropped. So in that state, you you want to make sure that the requests that are reaching that service are limited, because what happens if maybe the service is just able to process 500 requests per second, and then you just bombard it with 2,000 requests in a second, it's just going to go down, and you just get uh, um, you get it's usually bad gateway or something like that. It's not be you're not able to access that service uh, anymore. So in because you don't want such to happen, you can implement your circuit breaker in a way that if we get to this point, if we get to this constraint, one thing we are going to do is make sure that we are not going to receive. We will be rejecting some requests. So we just reject some requests, and probably you can give a generic response to your customer. Maybe the service is down. Can you check after a minute? The other, the last one is the the open state. So it means that basically the application has gone down and we are not able to make requests to it at all. And instead of maybe returning internal server error, or maybe letting the customer keep waiting, and they don't know what's happening. In that state, you can just be drawing some just custom message. Maybe the service has gone down. We're getting back in a few minutes. Maybe someone might ask how does that come into building a secure backend service. So one thing is that circuit breaker can help you avoid issues like DDoS attack, uh, just like rate limiting, because if maybe the application is not able to handle a certain load of requests, instead of it going down or shutting down completely, we're able to make sure that the application is able to handle uh, uh, whatever request it can. So that's on circuit breaker. I don't know if there's anyone with a question before we proceed. All right, seems that we're swimming on the same boat. The other thing we can talk about on securing application, a minute. We talked about circuit breaking. We talked about rate limiting. We talked about input
Charles,
validation. Yes.
just a question I'm getting. Is there a breakdown of these topics, or we take notes as you speak? This is the Is there slides on what you're speaking on?
Well, I think I had mentioned this. I'm sorry they
Okay.
didn't get it. I said more. Most of them are just coming from the mind. I didn't manage. Okay, I don't. I have a very short slide, like three pages, and
Okay.
I, I wanted this to be a discussion where we're just talking about like this thing, but it's something I can be able to compile after this and be able to share with you so that you can share with the team.
Okay. Thank you.
Okay, so back to where we were. Uh, we we had talked about rate limiting. We had talked about circuit breaking and input validation. Maybe the other thing I want to talk about is authentication. Now, for most systems nowadays, you find they are authenticated, and most of them use JWT or maybe JSON Web Token. And JSON Web Token basically is just it just helps us be able to generate a token based on some parameter user information that we have regarding this user, and be able to maybe authenticate them within a certain period of time. When we talk about maybe logging in, when you're logging into a system, uh, in most instances, we're just generating some token with your information, with your credentials, and we don't need to keep uh, sending back and forth your credentials back and forth to be able to authenticate the user. There are best practices when it comes to doing JWT authentication. Like one of them is how long does a token last, and how strong are your keys when it comes to your secret keys in generating the token. Um, hmm, is there anything around the same? And maybe before that, you can just make sure before you authenticate this user, you're checking the strength of the password you're giving to this user, just to make sure that maybe if someone tries to, you know, guess or do some random stuff, they cannot be able to do that. So when it comes to implementing the JWT token, uh, you have to make sure that before maybe you use the password to generate the token, probably you're doing some sort of hashing to it, making sure that the password is not plain text, because JWT tokens are usually they are not private. They are somewhat public because they are being used to communicate. They are attached to the request. I'm not saying that you should expose your JWT. Remember, if you expose your JWT, someone can use it to impersonate you and make a request to a service, and the service will just think that this is just uh, a legitimate user trying to access the service, and they'll be able uh, to to do whatever they want. Um, so there are different ways you can make sure that you when you're generating the token, you encrypting your password. You could probably be storing, if at all you're storing this token, you find there are times you don't need to store them on the back end, but maybe there are instances where you need to store the JWT, the token. Maybe you can go an extra mile to doing something we call encryption of data at rest, which is something I'll mention next. So when we talk about encrypting data at rest, this means that in as much as we are doing all this stuff, making sure that before the data gets to a service, we're able to authenticate these users, say this is the particular user, and we're able to do all those sorts of validation. when we store our data in our database, we can make sure that the data we are storing is not in plain text. I'm going to demonstrate that in a few. We can encrypt that data and make sure maybe when we're retrieving, that's the time we are doing decryption. And also, encryption of data, it doesn't only happen on the back end or on the at rest. You can also do data encryption on transit. This just makes sure you add an extra layer of security on the user information and maybe on your request data. So I'm going to go ahead and do a quick demo of some of these things that we've talked about. Oh, just a moment. So I've built a simple API. Just go ahead and share my screen. That will help me demonstrate what I was talking about. So I don't know if you can see my screen. Can just let me know if my screen is visible.
Yes, it is.
Okay, perfect. So in this API, in this small API that I've built, I have done few of the things that we've talked about, and we're going to see. I have several endpoints. It was just a very simple application. So some of the endpoints we have endpoints that help a user to register, login, and probably get a refresh token. And I'll probably not go dive deep into how everything works, but I'm going just to demonstrate some of these things, how we're able to achieve them. So the first thing I'll demonstrate, okay, is data encryption at rest. So just do this. I had created a user, but let's go ahead and just create a new user. So you're just going to log in. Just make sure that my application is running. And let's just call this application, this user Shuja. And we're just going to use some random password. So one thing we'll notice is that in as much as this user is Shuja, once we're able to save this user on the database, we'll not be able to see Shuja. We'll just see some random string because there's some encryption being done for that data. So let me just go ahead. Okay, I need to create the user first. So let me just go ahead and register this user. That request, okay, yeah. So as you can see, even before I proceeded, the API was able to do some validation and make sure, and it didn't pick an empty username or maybe an empty password. So these are some of the data that some of the information we are talking about doing some validation. In as much as probably we didn't do an injection, since we didn't do a validation in this data, it means that user can just put anything in it, and we need to control that. So let me just go ahead and create this user called jar. Perfect. And as you can see, the user was created, and I was able to generate an access token for this user. So going on what this user don't need, in order to make requests to the other APIs which are authenticated, they don't need to provide me with the username and password. They just need to present to me this access token, and they'll be able to we'll be able to get to know that this is the user that and they want to access this type of information. One very important thing with JWT is that you can be able to store a lot of information. You can be able to store the user privileges, uh, information, which is key when it comes to maybe protecting some endpoint. Maybe an endpoint should only be accessed by an admin. So it's something you can do. You can be able to take this token, decrypt it, get to know if this user is an admin or maybe it's a normal user, and are they authorized to perform whatever action they want to perform. So I'm just going ahead. I'll just go ahead and try to access the secured endpoint without providing authorization. So as you can see, we're getting forbidden because that endpoint is secured, and we cannot be able to access it without providing an access token. So let me just go ahead and provide the authorization. It's the bearer token. And I'm just going, I'll just append the token we got from this response. So let's try to make that. So as you can see, now we're able to reach the service, but there's something else. There's something extra. We're getting a bad request because our request has empty fields. This is what I was talking about doing field validation. So we cannot just be able to accept any sort of data from the user. So I think we'll just grab this payload here, which has some data in it, and just slap it in here. Oh, I'm getting still the same bad request. Let me check what that could be. This cannot be empty. Should be name. Yeah, perfect. I think I was passing the wrong information there, or maybe a wrong key to it. And as you can see, we're able to access our secured endpoint, and we're able to get response from it, which is a 200. It's a success. From there, we're going to probably get maybe try to access this one. So let's just access the unsecured one. So for this one, we don't need to provide any information. We don't need to provide any authorization to it. So as you can see, we're just able to access it directly. So maybe not going deep into it, just giving a brief overview of how this works. Just a moment. So in the security configuration, whenever a request comes in, it usually, so for this one, I'm using a library in Java Spring Boot called Spring Security, which usually helps in every request that comes in before it reaches uh, your your controller layer, or maybe where the endpoint is getting that information. It's intercepted, and from there you can do different filters. So there's this security filter chain method, which you can be able to do some validation of that request. You can be able to set configuration for your cross origins, if maybe you want your service to be accessed uh, from different origins, you can be able to set those settings here. And maybe you can also be able to whitelist some IP. Maybe as you had seen, we had an IP that we were, not an IP, an endpoint that we were able to access it without providing authentication. So this filter helps in just doing those checks. And also you can do even more configuration, or maybe you want to allow uh, the the scripting, and maybe if you were to allow scripts, where do they come from? So for my service, I've set to none. There are different ways you can set. You can set this one usually takes a list, so you can set differently a list of different entities where your uh, your application can receive scripts from. Um, hmm. So something I had mentioned is that we'll check how our data is being stored on the database. So on my database, I'm going just to select all the users that we've created. So select uh, from from okay. So as you can see, the username, we are not storing it as a plain text. And maybe someone is wondering what will happen when you want to get this user information. So I don't know if time will allow, but it's something I can be able to demonstrate real quick by just creating a simple endpoint. Uh, let's just do it here. So we just do a simple endpoint that returns for us uh, get mapping. We just say we just want to get user, and if we pass the name of the user, we'll be able to receive that information. So um, just going to return response. Just going to return Let's go ahead and pass the name of the user right there. So in this method, we're just going we will just go ahead and fetch the information we want. So we'll just say maybe var user equals to the repository dot find user by name, and we're just going to pass our name right there, and from there we can just return some response entity there. Can just maybe give a status code of 0, which means maybe we got the user, or maybe we didn't, it was a success. And then we can just do a quick check if we found the user. So we can do user dot is present, and we're just going to if yes username found. We're just going to pass the username right there. User dot get, and we're just going to get the username of that user, or else if we don't find user, we're just going to say user not found. Okay, perfect. I think that's it. I can just restart our application right here. Just restart our application. So the application is up and running. Let me just hit this endpoint, and we'll see if we'll get an encrypted data for that user. So just generate. Just generate that. And for user, we had a user called Shuja. I believe that's the user we had. So as you can see, we're able to get the username. In the database, we have an encrypted string. An encrypted string, I believe, is this ID too. But when we're doing our fetch, we can be able to access the actual information that we want. The other thing that I had mentioned about, even though I didn't manage to complete this feature fully, was data encryption on transit. So I'm going to restart my service. Let me just go ahead and restart my service. And we're just going to try and hit the endpoint with plain data. So when you do data encryption on transit, it means that whoever is sending you data, or maybe this could be a web application, a mobile application, or maybe another backend service, needs to encrypt that data using some key which you have to provide them, or otherwise the information will not be the request will not be processed. So I'm just going to hit one of the endpoints that we've hit. I'm sure, okay, well, it's going to give an encrypted response, but I'm sure it will be having some issues. Let's check that out. So as you can see, this information is encrypted. We're not able to maybe get to know exactly what this information is if we don't have key to decrypt this data, and probably be able to read it as plain text. So I think wrap it up there. when we talk about the security on the back end, it's a broad topic, and we cannot be able to cover it within an hour. So I just rushed through some items, but maybe if you be interested, I'll be pushing this code to my GitHub repository. So you can probably scan this code. From this code, you go. This will lead you to my LinkedIn, but from there you can check out my portfolio where you have my GitHub account listed. So I'll be pushing this code together with and try to compile whatever we talked about today and the information we shared. And put it on a README on the same repository. I'll probably call it secure software development. Probably by the end of day tomorrow, it's something you can be able to find. So because of time, I think I'll wrap it up there. I don't know if there's anyone with a question or maybe a burning issue that we need to, and maybe I can answer quickly.
Okay, thank you so much, Charles. Questions? Yes, go ahead. Vita.
Okay. Hi, Charles. Hi, everyone. Thank you so much for the session. It was insightful. So, you talked about tokens, right? And I'm just thinking, because I have seen tokens that are valid for like a month. So then, how do you strike the right balance between user experience and security? Yeah, in regards to token validation, because you also don't want to require users to constantly re-authenticate. So, like, according to you, what's the standard validity of a token, regardless um of the nature of the application?
Okay, thank you for your question. So there is no like the valid time we can say that we can store a token for, but I want us to look at something here. So there's something we usually call refresh token. If you look at the response I got here, it had two tokens. It had an access token and a refresh token. So the way we usually do it is that we make sure that access token have a shorter lifespan than the refresh token. And refresh token it's only used once, and that's when you use refresh token only when the access token is invalid. So you can maybe if it's a web application or a mobile application, you can work with the front-end engineer. So maybe when they make a call and they get unauthorized, before they just return to the user that they need to log in again, they can use this refresh token and fetch a new token. So the way I had architected this, I didn't show, but it's something I can show real quick. Just a moment. We're just going to make a request with that refresh token. Where is it? And we'll be given a new token, a new access token. So there's an endpoint for that. Moment. Not there. This one, refresh token. So you can just hit this endpoint. Um, and where does it take in a refresh token? Just need to pass it as an authorization or something. Where? And this other one. Authorization, and it will just be there, and then we just pass in the refresh token. Okay. And as you can see, we got this response, which has a new token. So you can be able to fetch a new token even without requiring your users to log in again, log in afresh, and maybe provide credentials. So that's the essence of having two tokens, having access token and refresh token. So you can have your access token valid maybe for a day, but for refresh token, maybe for those users who will not be frequent on the application, you can make it valid for 7 days. So yeah, I don't know if that answered your question.
Yes, it does. Thank you so much.
Thank you.
Any other question before we close the session? Okay, so I'll give it back to you, Charles, for closing remarks, and then I can bring the session to a close.
Okay, thank you. Thank you everyone for uh, showing up to this session. It was, I believe it was an educative session. And in case you have, maybe you have any question, you can reach out to me. You can just DM me on LinkedIn, and I'll be able to maybe answer your question or maybe provide some guidance in case you want some guidance. So thank you, Hope, for inviting me, and I believe maybe in future I'll also get another chance to speak to this or some audience. Back to you.
Okay, thank you so much, Charles, for the session. It's been really educative. I think I've been jolting so many notes. I hope the rest of us were. Would also request slides, maybe also for those who are not yet employed and would want to go into secure software development and the likes, how to practice in the meantime, how to build their repositories, how to better market themselves. That we'd really appreciate guidance on that. Then, so just an overview. We've gone through the common threats to backend systems, API security overview, the different practices we can put into place to ensure that our code is secure, and uh, how to protect the data we are accessing that belongs to our clients or our users. So thank you so much, Charles, for taking the time to do this for us. And I hope it's broadened our view on even coding, even if you won't go into it as completely or as a major step. Just as someone in cybersecurity, you know what to look at when you're supporting those in software development or teams, or even you're in a software development team, or you're just working on a project at work. You have an idea on what vulnerabilities that code could be um, vulnerable to, and how to speak the terms with the software development team. So thank you so much, everyone, for attending, and I hope we have a lovely night. Bye.
Bye. Bye. Bye.
Bye.